So today we'll look at some basic statistics, and let's start with looking at different types of data. Statistics just characterize data and help you make decisions based on the statistics of the data. So we're going to look at drawing a graph of data using a histogram. Measures of central tendency, that just means mean, median, and mode. And then spread, we'll look at standard deviation. So, looking at data, data can be numerical or categorical. Another word for numerical is quantitative, and then categorical is qualitative. Numerical is measured or counted, and categorical is not measurable, like color, opinion, gender, or things like that fit into a category but don't have a definite difference numerically. Numerical data can be discrete or continuous. So continuous will be if you have an interval of real numbers. That means there are infinite possibilities within the interval. Discrete, there will just be there'll be a finite number of values in the interval, and often it'd be positive integers would be an example of discrete numerical data. So let's look at this question. And categorical or numerical? So we look at, this is saying whether they like or dislike math, and we can't measure liking or disliking. We can just look at, it's just an opinion, so that'll be categorical. Because it's just like or dislike. And then if 60 out of 100 students in the sample say they like math, then we would expect, or we could expect, that that same fraction of the population should like math, or might like math, or maybe has a high probability of liking math. Okay, and would this be numerical or discrete? So we have the score for each student is going to be numerical. We can measure the score, or the score has a value, and if we just look at integer values, then that would be discrete. We won't look at all the decimal possibilities. And is that numerical or discrete? So we're measuring height, so that's numerical, and we'll call it continuous because each student could have, if you measured exactly the exact height, everybody could have some decimal value to their height. Okay, so now let's graph the data using a histogram. We can also put it in order with a line plot or a stem and leaf plot, stem plot. So let's look at a line plot. We don't have to do this every time we do a histogram. We'll just throw it in here. So we have to go out to 72. And then we just start looking 63, 59, 60, 61, 62, 63. There is a value of 63, and then we'll go to 69. This is 72, 71, 70, 69 has a value. 68, 64, 63 again, 62, 69 again, 70, 72, 59, 67, and 65. Just by looking at the line plot, we can see a rough distribution of the data, and if we had to predict, if we randomly selected somebody, we would have a better chance of predicting the height by looking at this rather than looking at all these numbers that have no order and we don't know where they're concentrated. We'll do the stem plot in another lesson. We'll go on from here. So to make a histogram, let's look at the range, and the range is going to be the largest value minus the smallest value. Class width will be the range divided by the number of classes. So we have a range of 13 and we have to divide it up into 5. So that will tell us how wide each class has to be. And then let's make a frequency table. So we start from the lowest value, and then we add 2.6 to it, 61.6. We're going to include the 59, but not include the 61.6. And then we count how many scores, how many heights are in this interval. So that's going to be 59, and then there's 61, so there's only one value there. Start at 61.6, add 2.6, and that takes us to 64.2. And we look at that interval, 61.6 to 64.2. 5960, so 61.6 to 64.2, and we see that there are 4 values there. 64.2 to 66.8. 64.2, 65, 66.8. There's 66.8, and there's only 1 value there. We're going to keep adding 2.6, so that's 69.4 and 69.4. Now we have 4 values there. Add 2.6 and we go up to 72. Let's just include 72 in that interval. So now we look at the line plot. There's only 2 values there, so we'll put a 2 there. Then we can make the histogram. So this mark means we're not drawing this to scale. We skipped from 0 to 59. It has a frequency of 1, so we'll go up to 1. And then here we'll go up to 4. And then we'll go to 1, 4 again, and then to 2. And we can do this on the calculator using stat edit and you enter L1. Enter the data in L1, and then we go second y equals, and that's stat plot. We select the histogram, and I will show you the steps on the calculator. So let's start with stat edit, enter the data, and then we can do second y equals. Make sure that these are not highlighted because we're not graphing those. If anything is in your calculator there. Second y equals, enter. Then we highlight on and we select the histogram. Make sure this says L1. To type L1, we type second 1. Second 1 is L1. Right there. And to get a graph, we can just do zoom 9. Alright, let's not do that yet. Let's go to quit and then zoom 9. And then if we want to change the number of intervals, we can go to Window, X Scale, and if we wanted an interval of 1, then it would change how many intervals there are. And this we wanted a 2.6, so window, and we'll go to X scale 2.6. And the calculator is putting one more interval here, but if we wanted 5 intervals, we would just include that last one in this interval. Alright, so in IB we'll always use population statistics, and those are actually called parameters, but we don't have to worry about it for IB. This is mu, and it's the mean of a population. That would be all students at the school, and this is the mean of a sample. So in IB we don't worry about the difference between those, and on the calculator it's going to write this. So to find the mean, we already know how to do that, but why don't we look at some of the notation. If you looked up statistical formulas, they use sigma, and it's going to say add up all the x values from I equals 1 to n and then divide by n. But we know that just means 63 plus 69 plus add up all of the values from the previous problem, and we get 65.917. So that's the mean. And then we have the median, and the median is the middle value. So to do that, a stem plot is helpful. So let's look at if we put all the numbers in order, and we start with the tens place value, 50s, 60s, and 70s. And we look back here and find we have a 59. So on the leaf we would have a 9. Then in the 60s we have to look at all the 60s and find their ones digit. So we have 62, 3, 3, 4, 5. We have 2, 3, 3, 4, 5, 7, 8, 9, 9 in the 60s, and then in the 70s we have 70 and 72, so we'll just put 0 and 2. So we can find the median here. This is a good way to put it in order. But for finding the median, why don't we put it all on a number line, and we're going to look at or it's not on a number line, we're just going to put it in order. So to find the middle number, we need to find the mean of these. So this is the ordinal numbers, first, second, third, fourth. So you have all the data, and then we have first through 12th. Well, to find the middle one, if you didn't know where the middle was, you could always do 1 plus 12 divided by 2, and we get 6.5. So that tells us that the middle value is between the 6th and the 7th value number. So that means we're looking right here. If there are two middle numbers, then we'll find the mean of those numbers. 65 plus 67 divided by 2, 66, and that's the median. So we have mean, median, and then mode is the one that occurs the most. We can look back at the line plot, and we see a 2, 2, so there are two modes, 63 and 69. Okay, standard deviation, it's just a formula, but to help you understand why it is the way it is, let's look at some simple sets of data. And standard deviation. Well, deviation refers to deviation from the mean, and then standard is just I think they chose that because it was an accepted way of finding out the average deviation from the mean. So if we look at A, and we have 3, 4, 5, so we see that these values are a distance of 1 away from the mean. We would say that the mean is 3 plus 3 plus 5 plus 5 over 4, and that equals 4. So the mean is 4, and every value is a distance of 1 away from 4, so we could see that the standard deviation is 1. But to look at what the formula is going to be, and we would say that, and this is sigma. Sigma stands for standard deviation. We can start developing a formula. We're going to go 3 minus 4, because that shows the distance of that value, and then we'll do 3 minus 4, so that's the distance of that value away from the mean, and then we'll have 5 minus 4, 5 minus 4 divided by 4. If we do this, this is going to be negative 1 plus negative 1 plus positive 1 plus positive 1, and we get a 0. So one way to take care of those negatives is just to say, let's find the absolute value of everything. And that is a measure of spread or dispersion, but the standard deviation just squares everything. So by squaring it, we make everything positive. And in this case, squaring it is not going to increase the value because it's just 1, 1, 1, 1. But if this were a 2 and we squared it, it would be a large value. So that's why once we square everything, we would need to square root to take it back down to its original level. And if we do all that work, we get 4 divided by 4 is 1, square root of 1 is 1. So the standard deviation is 1, and that's how the formula, that's the meaning or the reason for all the different parts of the formula. Okay, pause the video and try this one. Here we have 2 2s and 2 6s. the mean is going to be 2 plus 2 plus 6 plus 6 divided by 4. And we can see the mean is still going to be 4. And we can even see that the standard deviation, everything, is 2 away from the mean. So we already know the standard deviation is 2. And the formula would look like this: 2 minus 4 squared, 2 minus 4 squared, 6 minus 4 squared, divided by the number of things that, number of values, and then square root. So if we do that, we get 2. Okay, pause the video and try this one with 2, 3, 5, and 6. And the data is symmetric. It's centered on 4, so we can still see that the mean is 4. But now the standard deviation is going to be a little different than what we expect. If we see that half the data is 2 away and the other half is 1 away, maybe we would expect the standard deviation to be 1.5. But due to squaring and then taking the square root, it changes. It's a little different from that. So we're going to say sigma is 2 minus 4 squared, 3 minus 4, 5 minus 4, 6 minus 4, divided by 4, and we get 1.581. So that's a little different than what we expected. It looked like it should be 1.5 and now it's 1.581. But we'll just stick with that formula. That's what everybody uses. If you do this on the calculator, we go to Stat, Edit, let's just use this one, this list, and we'll go 2, 3, 5, 6. 2, 3, 5, 6. And then it's going to be Stat, Calc, 1var stats. Just give it the list. We don't have a frequency list, and then we'll calculate. This will give us the mean, and we will always use sigma for standard deviation. We won't use S. That's the sample standard deviation, and we're not going to use it in IB. We also have other statistics down here. It finds the median, and also quartiles, which we'll see in the next lesson. And I'll stop there.